Okay, guys, welcome to the next lecture. I've got a short lecture for you today, only about 90 slides. Uh, I'm actually going to try to go through them pretty fast, and then hopefully you guys will have some time to spend with WinSteps at the end, and you'll have AJ there to help you get through some of the screens. So hopefully we'll finish up pretty fast, and then the rest of the class will be a lab. So we're going to start with a little critique of psychometrics today. As I said before, you'll see some of these slides again, and then I'll elaborate it in different ways. So you guys know that the essence of psychometrics is that we break big decisions down into small decisions. I can't just ask you, what is your personality like? I have to ask you something about your personality. I have to pick out a personality trait, and then once I've done that, then I can ask you many different questions about that personality trait. We try to come up with many different items which are nuanced in some way, but still get at the essential theme of that trait, and then the signal accumulates in the overlap of the items. One of the questions that we're faced with, since this class is about inventory construction, is where do the constructs come from? And we have two broad approaches that we can take, either the inductive model or the deductive model. In the inductive model, we go to the world and ask what the world has in it. In the deductive model, the constructs are actually dictated from the theory. So when we have previously talked about the three-stage model of inventory construction, the three-stage model of inventory construction is really more appropriate to the deductive model. In the deductive model, we try to identify the fundamental axes or polarities of personality, and then it's different combinations of these that give us the constructs. So the theory actually gives us the constructs. The constructs follow deterministically from the theory, and then we can engage this three-stage process and we can begin constructing our inventory. The inductive model is actually a little bit different, because in the inductive model, we're building our inventory from the ground up. And in the inductive model, the process of creating a taxonomy and building an inventory is really pretty much the same thing. So we've got some fundamental decisions that we have to make. We've got a slightly different set of stages because we're building things from the ground up. At the bottom here, you'll notice that the first step is really definition and sampling. We have to decide from where our constructs will come, where will our constructs derive, and we have to decide what qualifies as a construct. So for example, if we want to derive a taxonomy of personality, Gordon Allport wrote the book Personality, simply called Personality, in 1937, just thus defining the field, giving the field its origins. Allport decided that all evaluative terms would be stricken from having anything to do with personality because he thought they weren't necessarily scientific. And that then ruled out the study of character strengths and virtues for the next 50 years. People who followed Allport, importantly, who did lexical studies, this eventually led to the Big Five model. So we have to decide where our constructs are going to come from, how are we going to draw the boundaries. Once we've done that, we can make some major decisions about the structure of our inventory. We can decide whether we're going to group the constructs conceptually, or maybe we're going to group them in terms of some kind of factor model or even a circumplex. So we decide what our sampling definition is, then we make a decision about the higher order structure of the inventory. After we do that, then we're in a position to actually talk about the construction of our scales. And we can think of our items. We've got our traits at this point. We can think of our items. We can look at the internal consistency of our scales. Scales that have low internal consistency might be broken up into two scales, for example. And then when we're done with all this, we would have a taxonomy and a test at the same time. The process of deriving a taxonomy and inventing a test are essentially the same thing. And we can apply this model to either the development of one scale or the development of many scales. Historically, people have applied this to the development of one scale. It's simply been easier in the past. Decades ago, the computational resources were not necessarily available to do the kind of sophisticated statistical analysis that we can do in microseconds today. The problem with deriving only a single scale is that, well, you can't really look at a matrix of the item scale correlations. Remember that the construct is supposed to be the cause of the item endorsements. If you did the assignment where I was absent a couple of weeks ago, you probably noticed that many of the items that you thought were right on construct were actually more highly correlated with other scales. You can't carry out these calculations when you're only deriving one scale, and that means that your one scale may tend to be less focused, so that's typically a problem here. In other words, it's probably better, if you want your scales to be focused, it's probably better to derive many scales at the same time. Once you have a list of scales that you want to go into your inventory, you have to come up with some way to group them. As I said, you've got a variety of different choices. This is just the conceptual grouping that's associated with the VIA. You can see that the character strengths are grouped into courage, humanity, transcendence, temperance, justice, wisdom, and knowledge. These are the major domains of the VIA. The organization of these is really unimportant. I just want to show you some examples of higher order organization and make the point that a conceptual grouping is one of these. Here is an example of Hofstede's circumplexes. This is derived actually from the five-factor model. Hofstede said that instead of just having 5 factors, what we need to do is study personality as combinations of these factors. So this particular circumplex crosses introversion, extroversion with openness. So we've got introversion, extroversion as the vertical dimension, and creative, unintellectual as the horizontal dimension. So if you're extroverted and unintellectual, you're supposed to be verbose or pompous. If you're unintellectual and introverted, you're predictable or apathetic. And Hofstede said that personality should really be considered in terms of this circumplical space, and by crossing the 5 factors of the 5-factor model 2 at a time, he derived 10 different circumplexes, and that was his higher order structure. This is just an image that I found on the internet. This is probably the results of a multidimensional scaling that was applied to the VIA scales, and you can see here that they've derived what they think are 2 dimensions for the VIA scales, one focusing on mind and heart and the other focusing on self and others, and then they've got the scales of the VIA scattered around the edges of the circumplex. And again, the structures of these that I'm showing you, the structures of these models are actually unimportant. I just simply want to make the point that they exist, and that at the level of higher order structure, you have different decisions that you can pursue in terms of creating your inventory. This is a different model of character strengths. Actually, it's motivational values. I'm not sure what the difference is between motivational values and character strengths. We'd have to test we'd have to check the definitions. But as you can see here, this is the Schwartz model, and we've got, again, a circumplical model. We've got openness to change as opposed to conservatism, self-transcendence as opposed to self-enhancement. Those are the 2 dimensions of the model. And then around, inside the space of the circumplex, we've got things like universalism, benevolence, conformity and tradition, and security. And you can see that the labels here are actually quite different than the labels of the VIA. So when you derive an inductive model, you've got different stages that you can go through. You're building things from the ground up. This gives us a standard plan of attack. If you wanted to develop a criticism of various inductive models, there are pretty standard methods of attack on any particular ones of these. Let's say, for example, that you wanted to critique the 5-factor model. The most fundamental critique of the 5-factor model is a critique of the sampling stuff. You can simply say that personality needs to be defined in a different way. So if you don't follow Gordon-Allport and you don't exclude evaluative terms from the definition of personality, then when you sample the dictionary, you'll end up with 7 factors instead of 5. Or if you change the sampling definition another way, you can end up with 6 factors instead of 5. So at the most fundamental level, you change the way the boundaries are drawn, and since it's an inductive approach, you're going to be applying factor analysis or some form of modeling to this. The overall resulting structure changes as well. So you change the boundary definitions, or maybe you decide that I'm going to pursue, in one instance you decide that you're going to pursue a hierarchical factor model so that everything has this tree-like structure the way the Neo-PI does. In another instance, you decide that you're going to pursue a circumplical model like Hofstede's model or Schwartz's model, for example. And when you think about it like this, when you think about inductive models being built in terms of these 3 or 4 stages, and you realize that there are certain fundamental questions that are being answered at each stage, what you realize is that the Neo-PI and the Hexaco and Hofstee and countless other models that are trying to be comprehensive models of personality, that they really define this kind of tree-like space. So you have the sampling decisions that are being made down here, and then you have a higher order architecture decisions that are being made here, and then you have some lower order decisions about what items you're choosing into your scales here, and then the leaves of the tree or the endpoints of the branches here. These are the various models. And you can, if you want to make a name for yourself, just decide to change the boundaries a little different and explore one of the branches of the tree that's previously been unexplored, and you can invent an inventory and you can make a name for yourself in psychology. Okay, and you can have a little label out here that is at the endpoints of one of these trees, the endpoints of one of these trees in the decision space. The question here is whether this is really scientifically satisfying, because in psychology you have to do things like evangelize your own models. You can have the best model in the world, but unless you're out there actually speaking on the model and publishing with the model, then nobody's actually going to take your model seriously, and your model is going to be in the pages of the journal, and it's not going to attract any followers. So you may come up with a great model. It may exist in the pages of the journal. Marketing becomes an extremely important thing. What's important to know is that an inventory tends to crystallize a movement. We've got a lot of different traditions in personality, like the cognitive tradition, for example, or the lexical tradition. Until an inventory comes along, momentum really doesn't build in a strong way. Think, for example, how much the Neo changed things. The Neo comes along in the mid-1990s. Before the Neo, before the five-factor model, there was the Big Five model. The two things are obviously related. But until the Neo came along, it really didn't have a whole lot of momentum. And when the Neo came along, everything changed, because suddenly the tradition had an inventory that was associated with it. People could actually begin to measure things, and they could begin publishing studies. So you begin to see the Neo over and over and over thousands of times in the literature. The problem with this is that when you think about this space, this decision space in terms of inventing inductive approach to inventory construction, it gives the field a kind of accidental character. We would like science to converge on a single result. We have this idea that we've got many different scientific theories and that experiments are filters that the theories have to pass through. And sometimes the theory is in accord with the empirical evidence, and sometimes it is not. Theories that are not in accord with the empirical evidence are simply rejected. They fall into the trash basket of history, and they may be revived again or tweaked in some way, but for the moment at least they're out. And we think of experiments as being filters, and then when a theory has passed through enough of these filters, when it's stood the test of time, it's had a trial by fire, then we think of the theory as being entitled to be called the truth. So, but this is not how things actually seem to work in terms of inventory design. In terms of inventory design, we seem to have this tree-like model where we can make different decisions, and the tree gets explored over the history of the discipline, and things don't seem to actually converge on a single result. So the deductive criticism of this, if we take a deductive approach to personality, people who are into a strongly theoretical model, they will say that the problem with induction generally, induction, we go to the world and we see what the world has in it, but when we go to the world, we take our common sense conceptions to the world as well. And we never really seem to break free of those that common sense way of talking about the world. We never really seem to break free of that. Factor analysis is not going to do it for us. The people who are into a strongly theoretical approach would say that in the evolution of science, science involves the creation of a scientific or professional language. And that after you've studied the domain, well, then somehow some genius in the field has to come up with the core organizing principles, and then the taxonomy tends to be reborn in terms of these organizing principles. And if you look at the history of sciences, we've seen this over and over again. So for example, you've got Mendeleev in the periodic table. At one time, not all of the elements are known today, but at one time only a smattering of the elements that are known today were realized by chemists, and Mendeleev actually had to find an order in this, and the underlying principles that he found actually predicted elements that didn't exist. Or another example would be Einstein and the theory of relativity, and still another example would be Darwin and the principles of evolution, and then the taxonomy for biology would be this tree-like structure known as the tree of life. So that doesn't really seem to be happening in psychology. Instead, we're exploring this space in terms of creating inventories and models, and it doesn't seem to converge on a single result. What is clear, however, is that when you are asked to construct an inventory, which is the subject of the class, you're being asked to architect an entire domain. And the entire domain could be personality, it could be abilities, it could be emotional intelligence, it could be many, many, many different things, but you're being asked to derive an inventory which effectively functions as a taxonomy for that domain. Now, in opposition to that, which is a situation in which we don't have the field converging for on a single result, in opposition to that, we have the Rasch model that takes a very strongly theoretical approach. And in the Rasch model, phenomena are supposed to emerge in an orderly fashion, similar to development. So you can think of this idea occurs many times over psychology in many different forms. You can think of this as being life stages. So at the bottom level, you have a caterpillar, and then all caterpillars become pupas, and then they go on to become butterflies, or as we've talked about, addition, subtraction, multiplication, and division, or even Maslow's hierarchy of needs. So you've got the phenomena emerging in an orderly fashion. The order of this orderly emergence becomes the item hierarchy, and the items are actually dictated by the theory. So this is a slide from the last lecture. Maybe you have a theory about religiosity, for example. You've got some items that you've generated in accordance with your theory. Here's your ruler. You've developed your scale on a normal population. But what you would like to do is be able to apply the scale up here. Maybe you don't have any really religious people that are in your sample, in your normative sample when you develop your ruler. So the ruler is constructed on a normal sample. You need a way of adding more units. The Rasch model gives us a way of extending our ruler upward. And if you don't have equal units on a ruler, you can ask yourself, well, what is really the point of having the ruler? So the fact that we can extend the ruler and the fact that we have equal intervals between each point on the ruler, these are supposed to be the fundamental properties of measurement according to the Rasch model. And again, you see this idea all over the place. So I'm not going to go into this slide in any depth, but this is an interesting idea. Joseph Campbell is a guy who was very into mythology. He wrote a number of books. He's one of the most famous people in the field in terms of the study of mythology. Campbell had something called the monomyth, or the hero's journey, and this is he derived this structure as a result of his review of the mythological literature worldwide. And he says that every hero's journey follows a particular order, and if you want to, later on when you're looking at the slides, you can see how this monomyth actually applies to Star Wars and can be used to explain why Star Wars was so successful. So apparently there's an inner journey, an inner spiritual journey that the hero undertakes, and then there's an outer journey that also takes place in terms of what the hero does. So you could actually, since this is a stage-wise model, you could actually use this to develop items for a Rasch model if you wanted to. There's a formal resemblance between Campbell's monomyth, the stages that unfold as a result of the monomyth. It maps perfectly into the Rasch model. So it would be possible actually to develop a test for that. In personality, we haven't really been, historically, we haven't really been too concerned with this, talking about things unfolding in a stage-wise fashion. We're more concerned with identifying parts of the trait and then trying to come up with items that are associated with those different parts of the trait. So really, in personality, we've been kind of focused on just applying the Rasch model to trait items, to scale items, so that we can get the measurement goodness of the Rasch model, and then maybe a theory will kind of come out of that later. So just to review the Rasch model, as you know, it's founded by Rasch, who was a Danish statistician, and he asked the question, what happens when a person meets an item? And Rasch said that the relationship between person and item is a struggle. It's a probabilistic relationship. It's like a chess game or a tug of war. And in this situation, there is a probability that the person will win the tug of war, or that the item will win the tug of war. And when the person and the item are perfectly balanced, when person difficulty is equal, person ability is equal to item difficulty, then the odds of either one prevailing are actually 50%. So you have certain items that are very easy, and those items will be passed by the person all the time, 2 plus 2. On the other hand, if you have complex mathematical equations, then those items will be failed all the time. So the point that we get the most information about you is actually at this point where we're giving you many items that are approximately equal to your ability level. If I only give you vocabulary items that can be answered by 6th graders, there's going to be a ceiling effect. You're going to top out the test. The test is going to have very little validity for you, so we're not going to really learn much about you. We only begin to learn things about you when you fail an item. If you fail all the items, or if you pass all the items, then for you there's a ceiling effect or a floor effect, and essentially we learn nothing about you. If we take the test and we administer it to many different subjects, and we arrange the subjects in a matrix so that those of high ability are at the top and those of low ability are at the bottom, and the easy items are on the left and the hard items are on the right, then we've got this nice scalegram structure here. And you can see here is the logistic curve. Remember, the logistic curve traces the relationship of person ability and item difficulty, so that in the middle of the scalegram here we've got this transition zone, and then on either side of the transition zone we have a situation in which all items should be passed. These are, for example, right up here, these are high ability persons taking easy items, so we expect to see all items are passed here. This is a situation in which we have low ability persons who are taking hard items, so we expect the low ability persons to fail the hard items. So we have a lot of predictability over here on the edges, and we have a situation here in the middle, which is a transition zone, where the difficulty of the items are approximately equal to the ability of the subjects, and we have this like zone of chaos here in the middle. The question for us is, how do we turn this qualitative data that consists of ones and zeros, how do you turn that into a scale that has equal intervals and this property of additivity that is so fundamental to measurement? The key thing to notice here is that the matrix consists of zeros and ones, but that we can construct proportions in the margins. The problem with the proportion is that it only varies from 0 to 1, though. So 0 to 100%. 100% is a proportion. When you were a little kid and you received an arithmetic test, well, you brought home a 99 and that was great, but it still wasn't a great measure of your ability because it only varied really from 0 to 1 or 0 to 100%. So how do we transform this, this proportion that has a finite variance, how do we transform it into a scale that potentially goes on to infinity? And the answer to this question is that we take the natural log of the proportion. So we add another column and another row down here, and then this ability logit is actually the natural log of the proportion, and this becomes the first estimate of person abilities in this column, and this becomes the first estimate of item difficulties in this row. And then WinSteps and other software actually begins to fine-tune these numbers and tries to reconstruct this matrix, and when the number of mispredictions is minimized, then that becomes the final person abilities and item difficulties. So here's the matrix right here. We use this nice construction of proportion and then taking the natural log of the proportion in order to get the person abilities and item difficulties, and then that allows us to put the persons and the items into the same frame of reference. So we go from the matrix here to this nice frame of reference called the person map, And we can see here, we can immediately look at this and get an idea of targeting. So in this particular situation, we can see that overall the items have more difficulty overall than the persons have ability. Okay. This is actually on WinSteps. This is actually on the output tables menu, and then you go to table 12 item map. So Lineker has all of the items numbered. The problem with the item map is that it's a little bit deceptive. If you're working with dichotomous data, then this would be okay. We're actually working with Likert type data. So when you look at the item map, you're looking at the mean of the different levels, the mean of the difficulties of the different levels of the item. The item map actually doesn't show that to you. So even though you see this item here, this item is actually prefer fear to boredom, and it's supposed to it's right at the mean of the item difficulties, okay? But actually this is a Likert type item, and the different levels of the item are actually going to span up and down on either side of this. So when you look at the item map, just be aware that it's a simplification. And then another thing that we get from the Rasch model that's nice, since it's a Likert type item, each level of the Likert type item has its own level of difficulty that's associated with it. If you have more of the trait, then you should be up here somewhere. If you have less of the trait, then you should be down here somewhere. And the different levels of the trait should be spread equally because they co-vary strongly with the trait. If you have an item that really doesn't belong to the construct, well, the different levels of the item are going to be disordered, and they're going to be close together. So we look at actual data. This is submissiveness, and you can see that for most of the items in submissiveness, yes, the different levels of the Likert type item do co-vary strongly with the trait, and they're fairly spread out, except for this one. We'll agree to anything. For whatever reason, the levels of the item are very close together, so the item is supposed to be narrow. This item isn't offering us any discrimination. Its discriminatory power is limited because the levels of the item are very close together. And the purpose of a test is to spread the sample apart, obviously. So the test is supposed to have a certain amount of discriminatory power. The item should have discriminatory power as well. The different levels of the item do not have that discriminatory power here. So this is going to be a bad or narrow item, and this item could probably be rejected. Okay, so let's just go ahead and we'll review WinSteps real fast. Go ahead and load the anxiety TXT file. If you just find the file, you can find the file in on your desktop somewhere and load it up. If you double click it, it will automatically load into Notepad. You guys are with me? Okay, so when you load anxiety.txt, when you actually look at the file in Notepad, what you find is that the file has 3 regions that are associated with it. At the top, you have a region of commands. That's followed by a region where you have your items and your item text. And then below that, you actually have the data, the raw item data down here, which is the 3s, 4s, and 5s. And then that may be followed by some person variables. Here, in this case, we have the gender of the persons as well as the spelling of the person's names. So the file structure of WinSteps, it's actually divided, the command files are divided into 3 regions. I want you to take a look at one of the things that I want you to know here, since you're going to actually be doing some of these calculations in class later, you'll actually be using WinSteps, is how do you do item selection in WinSteps? And there's a couple of different ways to do it. WinSteps is a very flexible program. So if you look at the command file, you'll see that there's this line down here, iDelete equals, and that's followed by a series of numbers. Each one of these numbers are items. If you were to uncomment this line, remember in WinSteps, everything after a semicolon is a comment. If you were to uncomment this line and run the file, then items 3, 9, 10, 11, and 14, 14 and 7, these items would be deleted from the analysis. Okay. Second way of choosing items in win steps, we can use what's called the iSelect command. So here is iSelect equals FFM, and there's a line underneath it, iSelect equals hex. So in this particular file, it combines the anxiety items from the 5-factor model and from the hexaco model. So if you were to uncomment one of these lines and run the analysis, you would select either the 5-factor model or the hexaco items, and the others would be deleted. So what iSelect tries to do, it tries to match these 3 characters against the first 3 characters of the item. And if it finds a match, then that's included into the analysis. So go ahead and start win steps and run the anxiety.txt file. If you can start win steps on the file menu, you should find a link to recently used files. And since we dealt with anxiety.txt last week, that should be on the list of recently used files. So if you can just start win steps, that's half the ball game. So were you guys able to actually run the file? Raise your hand if you succeeded.
A vast virus database has been updated.
Okay, so we'll just go over the item polarity table. We'll briefly review that from what we did. We talked about this last week, but we'll review it again. And this is going to be the workflow in WinSteps, that you'll start WinSteps and then you'll run a command file. You'll look at some output. You'll make changes. You'll edit the command data file. You'll save the file, and then you will exit and restart WinSteps. So most of this will actually take place on the File menu, and then this whole process will repeat, and that will be the workflow of your analysis. So go ahead and call up the item polarity table. This will be on the WinSteps diagnosis menu. You'll see this is A. Mike Lineker has been generous enough to give us a menu that's called diagnosis. Most of our workflow actually takes place there. So if you go to the item polarity table on the diagnosis menu, we changed some items, we changed some scoring directions from last time, so you should come up with a table that looks similar to this. And on the left, you'll see the entry number. Okay, that's right here. This is the number of the item. This is the item number. It says entry number, but it's actually the item number. Okay, so if you were using the iDelete command and you wanted to, maybe you decide that this first item here, since it has a point measure correlation, an item scale correlation of 0.22, maybe you decide, you know, that's really too low. I want to get rid of that item. So if you're using the iDelete command, you would enter 10 after iDelete. Okay, so you would put that into the iDelete command, and then this item would not appear in the next run of the analysis. Okay, then there's the measure column. We're just going to go over the most important columns. There's the measure column. This is the difficulty level of the item. Now, by convention in the Rasch model, the mean of the item difficulties is 0. Okay, the mean of the person abilities may be far different depending on what the targeting is, but in the Rasch model, the mean of the item difficulties is 0. That means that these numbers collectively are going to be roughly centered on 0. They're going to vary from some negative number to some positive number. And then these are the item difficulties. So this is the most difficult item, this 0.97 here. This is the most difficult of the items. And then the easiest item will have the lowest negative values. So the easiest item is here at a negative 0.88. And all of the other items are going to be in between that. Okay. Then infit and outfit, there's a couple of columns here that are associated with infit. The MNSQ column is by far the most important of these. As we talked about in terms of infit the last time, infit is called an information weighted index of fit. It gets at whether or not this pattern of ones and zeros is predictable inside this transition zone. Okay, since this is a transition zone from success to failure, we expect to see mostly ones over here on the left and mostly zeros over here on the right. The problem with this is that it's highly influenced by sample size. The Z statistic, this gives us the significance of the fit. Any value greater than, say, 1.96 would be P equals 0.05. So any value outside of 1.96 to minus 1.96 is going to be significant at a 0.05 level. But as I said, this is highly influenced by sample size. The mean squares put the fit statistics all in the same metric. So you're going to be looking at this column to decide if an item has bad fit. The values that you're going to be looking at in a rating scale context, you're going to be looking for values greater than 1.4 or values less than 0.7. Okay, and then outfit is essentially the same way. In outfit, remember, we're concerned with whether or not the person failed items that should have been passed or passed items that should have been failed. These are the zones on either side of the transitional area. Again, values greater than 1.4 or values less than 0.7 are going to be suspicious. And then we have this column, which is the point measure correlation column. This is the item scale correlation that you're familiar with, except it's not the corrected item scale correlation. In SPSS, we receive the corrected item scale correlation. We don't receive that in WinSteps, and as a result, there's some amount of incestuousness here because this is really the correlation of the item with the scale with the item included. So the correlation is somewhat inflated. The real values are probably around 0.1 to 0.15 less than what you see here. Okay? Ordinarily, in a classical psychometric context, we would use the item scale correlation in connection with alpha to decide whether the item belonged to the scale. Here we can't really do that, or actually we can do that, but it has less weight. Mike Lineker, who is the guru on this stuff, says that in Rasch analysis, we are chiefly concerned about the predictability of the data when assessing item quality. So we examine the predictability directly using the mean square statistics rather than indirectly using correlations. Okay, so you've got a couple of things that you're going to be looking at. You're not going to be just looking at this column when you do your item selections the way you were when we used SPSS. You're also going to be looking at the infit and the outfit and also the item difficulty, okay, and the empirical item categories. So there's a lot of different information you're going to be looking at when you make your item selections. Now, because we're not just looking at the point measure correlation, we come up with these funny situations, and there are some subtleties, there are some nuances here that you have to understand. We come up with these situations in which the correlation of the item with the scale is actually somewhat low, and we wonder whether we should keep the item or reject it simply on the basis of the item scale correlation. And you'll notice with this particular item, well, let's look at the one that's 0.22. Here's a situation where the item has a low item scale correlation, and as you can see, the fit statistics, the infit and the outfit are both above 1.4. 1.4 is the zone where we begin to become suspicious. So since the item has a very low correlation with the scale, and since it has marginal or bad fit statistics, well, we can just go ahead and throw the item out. This item is a little bit of a different case. Yes, the item scale correlation is low at 0.25, but the fit statistics are okay. The fit statistics are constructed so that they should equal 1.0. All right? So the fit statistics for this item are just about as close as they can possibly get, even though the item scale correlation is low. And we ask ourselves, is that a good item or a bad item because the correlation is low and yet the fit is okay? And in order to understand the answer to that question, you really have to understand the theory on which your items are based, and you have to understand targeting. All right? So we might be developing, say, a scale which measures stages of paranoid development. And if you look at the theory behind different stages of paranoid development, what you find is that most theories talk about early abuse that leads to some kind of general emotional distancing. It could be early physical abuse, it could be early emotional abuse. But on that trust versus mistrust, on that first stage of Erickson's, which is so important, the person tends to develop a mistrust orientation. And because they develop a mistrust orientation, they begin to perceive others around them as being malevolent, as not necessarily having their best interest at heart. They begin to select for this information. They don't see the instances where other individuals are actually trustworthy or compassionate. That stuff doesn't get processed at all. So they tend to see the world, the entire world around them, in terms of its malevolence and potential for mistrust. And you can imagine if you viewed everybody in life as being this way, you would probably have a lot of anxiety, and you would probably have a lot of anger about the way they were treating you. And ultimately, that could lead you to believe that the people around you were conspiring against you. You might wonder, why are people being so mean to me? Why are people picking me out? And then there's supposed to be this moment of paranoid illumination where everything suddenly makes sense and you realize that you are the victim of a conspiracy, and this marks your break with reality and your descent into a schizophrenic psychosis. So if you were developing a scale that was designed to assess these stages, you might not have a lot of paranoid subjects that were readily available to you. You might only have college students, right? College students are the most studied population in the world. And because you have only college students that are available to you, the items that tap trust versus mistrust, those items would get endorsement. The items that tap anxiety and anger, those items would get some endorsement but less endorsement. And then the items that actually tap ideas of reference and paranoid psychosis, those items might not get any endorsement at all, or very little endorsement. So if you were developing this scale with only college students, you would be in a situation where, yeah, you've got a strong theory and you've got an item hierarchy based on the theory. So you've got the potential to develop an interval level scale using the Rasch model, but the item scale correlations are very low because the items are so difficult. All right? So the items that, if you were developing this using college students, the items that tap the more psychotic ends of paranoia, most students are going to answer this stuff false. The item scale correlations are going to be very low. In a classic psychometric context, if we were doing the data analysis with SPSS, we would look at these items and say, uh-oh, low item scale correlation, low alpha, the item contributes to low alpha, throw it out. In a Rasch context, we actually can look at an additional statistic. We can look at fit to the data, infit and outfit, and we may decide that the item is consistent with the theory. The correlation is low because the targeting is the problem, and therefore I'll go ahead and keep the item. Okay. That may sound like an extreme example to you, so let me use something that's a little closer to home and closer to the inventory that we've been constructing. Think about Maslow's hierarchy of needs. Maslow talked about you might want to invent a scale which would assess how actualized you are. Maslow talked about self-actualization as something that occurs to very few people, so presumably items that were up here in this self-actualized part, items that got at the most actualized people, or as actualized as you can be, these items would also get very few endorsements, even though they're in accord with the theory. That is, if you are developing the scale on college students. All right. So we go back and we look at this item. This is item 11. Go to the item polarity table and scroll down. And when you scroll down, you're going to receive a frequency table for each of the items in the analysis. And this is a little excerpt that shows this item, item 11. And we can see that, in fact, this item is very skewed. Okay? So we've only got about, this column here gives the raw frequencies of subjects and how they answered on the Likert type item, and then this column gives the percentages. Okay, so we can see that only about 12% of the subjects are answering here either strongly disagree or agree. Okay, so definitely this is a difficult item. If we go to the output tables menu and then to the item map, we can immediately get an idea of targeting here. And we can see that this is the most difficult item in the sample because this item is at the top. So in order to get this table, go to Output Tables and then go to the item map. The Output Tables menu, then to item map. Is everyone able to get this table? Okay, raise your hand if you have this table. Okay, great. All right, so you all were able to get the item map. And when you look at the item map, you'll notice that this item is the most difficult item. Of all of the items, this is the most difficult item. The most difficult item here is at the top. Maybe that accounts for the 0.25 correlation, the 0.25 item scale correlation. So it's a judgment call. Do you believe that the low item scale correlation is a result of the difficulty level of the item? You're not going to be able to decide that simply by looking at the measure column of the item polarity table. The reason that you won't is because the item difficulties are centered on 0. All right? So in order to make this kind of decision about an item, you're actually going to have to check targeting. So you're going to have to go to this table. Okay. Now, if you were designing a scale and you wanted your scale to assess the entire range of the construct, well, there's an interesting fact about this. These early items that get at early stages of development of trust and mistrust, maybe you want to design a scale which assesses the antisocial personality. Maybe you want to design a scale which assesses paranoid personality. Both of these things presumably have their origins in early abuse. These items tapping early mistrust could be common to both scales because they would be common to the theory of both scales. Okay? So you might actually have some item overlap here. All right. The problem is that historically and later on when we take a look at the VIA data, you guys are going to be analyzing the IP VIA data in class there with AJ. The problem is that historically we haven't really thought of personality traits or character strengths in terms of this strong theoretical model that goes so nice with the Rasch analysis. So as a result of that, the decisions on whether the item really corresponds, if there's really an item hierarchy there, well, we don't have a strong theory of the construct that lays the items out in this way. So things may be fairly fuzzy to you. Another thing that you're going to consider in making item selection decisions is the empirical item categories table. Okay? I want you to go ahead and open the VIA for class.txt file. You can go ahead and open it in Notepad if you want, or if you're really ambitious, you can start WinSteps. You can go ahead and start WinSteps and run this file and then open it from the edit menu. Okay, were you guys able to open this file? Okay, so once you open this file, scroll down and you should see a couple of lines here. One is commented out. It says second way of choosing items. And then underneath that it says iSelect equals CURI, Curie. And that means that we're going to select into the analysis items that belong to the curiosity scale. So if you scroll even further down, what you'll see is that each item begins with a scale of 3 or 4 letters that are basically an abbreviation of the scale name. So ABE, for example, is appreciation of beauty. CURI is the abbreviation for curiosity. iSelect equals CURI is going to select into the analysis items for the curiosity scale. So go ahead and run that. Go ahead and run that in WinSteps. Okay, once you've run it in WinSteps, look at the item polarity table. Okay, go ahead and look at the item polarity table. Remember, item polarity is on the diagnosis menu. Are we all together? Okay, great. So when you look at the item polarity table, you find that there's this weird situation where you have this item, am interested in many things, it's item 81, and, well, the items in the item polarity table are ordered in terms of their correlations from lowest to highest, the point measure correlations in this column, and the correlation between am interested in many things and the scale is negative 0.34. So the first thing to make sure of is that you don't see any negative correlations here. We want all the correlations to be positive. This is telling us that the item is scored in the wrong direction. And so the question is, how do we change the direction of the scoring of the item? Okay, so we're going to get to that in a minute, but first we want to look at the empirical item categories table. So go to the diagnosis menu and select empirical item categories, and you're going to pop up this table. Remember, all of the output in WinSteps goes to Notepad. So you'll pop up this table. Okay, so you pop up this table, the empirical item categories table, and we just want to see how an item that's keyed in the wrong direction looks in this empirical item categories table. And you'll notice that the item is at the top of the difficulty list. In the empirical item categories table, the most difficult items are at the top, and the easiest items are at the bottom. So this item is scored in the wrong direction. In other words, it's actually scored against the construct, so naturally the item shows up as being one of the most difficult or the most difficult items. But notice the different levels of the Likert type item here. You can see that for most of the items, the different levels are in order. They go 1, 2, 3, 4, 5. Or if the item is reverse scored, the levels will go 5, 4, 3, 2, 1. But for this item, which is scored in the wrong direction, the levels go 3, 4, 2, 1, 5. And that's completely bad, because what it means is that the strongly agree and the strongly disagree, the 1 and the 5, well, they're right next together here, and that shouldn't be the case. They should be at opposite ends, right? So this is how an item that's wrongly keyed will look on the empirical item categories table, and obviously we want to fix that eventually. Another thing to notice about the empirical item categories table is that there's kind of a gentle slope here. If you look at the 5s, for example, or the 4s, you'll see that they're kind of tilted to the right. So if we actually believe that we have an item hierarchy and that the item hierarchy corresponds to and is dictated by our theory, then we have the most difficult items. We should have some kind of a slope here, so that we have the most difficult items at the top, and then the most difficult levels of the most difficult items should be over here on the right, and then the easy items should be down here. To the extent that our items actually reflect an item hierarchy, we're going to see some kind of a gentle slope here in terms of this. And then the last thing to notice, the last of the features about the empirical item categories graph, is that at the bottom here you have a frequency table. So right here is the mean of the item difficulties, which is 0. And then this M here at the bottom, this is the mean of the person abilities. And then these numbers, which are above, these string of numbers, this is telling you, for example, that there are 19 people who are at the mean of the person abilities. Okay? So, and then just below the mean of the person abilities, there's another 46 people, and just below that, there's another 24 people. So the frequencies are actually arranged vertically here in order to save space. And then you'll notice on either side of this M, this mean of the person abilities, there's an S, and then at the outer side there's a T, and this is standard deviations. So the S is one standard deviation, and the 2 is another standard deviation. So if you understand what this frequency table means, you can kind of look at the relationship between the person abilities and the item difficulties here, and this is another way of kind of getting a feel for the targeting of the scale. And remember, since these are Likert type items, if they have one difficulty level, the measure column in the item polarity table is giving you the mean of the difficulties of the levels of the item. Here what we're seeing, we're getting much more detailed information here. Okay, we're getting information about how the different levels of the Likert type item span the trait. So even though the targeting is somewhat off here at the bottom, you can see that the mean of the item difficulties and the mean of the person abilities, there's some distance here by about, well, something over a logit. Okay, so even though the targeting is somewhat off, we still see that the different levels of the Likert type item extend far up the continuum of person abilities, and so the fact that we have Likert type items compensates for the poor targeting. Okay, so we want to change the scoring direction of item 81, and in order to do that, go ahead and go back to the file, and you could find a way to edit the file. There's an option to edit the command file on the file menu. So go back to the command file and then scroll down. So change the B to an A, and you've changed the scoring direction of the item. So that's your workflow in WinSteps. Edit the command file, save your changes, exit and restart WinSteps. So was everybody able to change the command file and exit and restart WinSteps? Okay. All right. So once you've saved your changes and exited and restarted WinSteps with your changed command file, go to the empirical item categories table again, and it's on the diagnosis menu. And we're going to take a look at how this table has changed as a result of correcting the direction of the item. And as you remember, before the item was the most difficult item, but the levels of the item were disordered and they were narrow. So now this time when you pop up the empirical item categories table and you find item 81, you'll now see that item 81, I'm interested in many things, is now an easy item. This is one of the first items that people endorse in the item hierarchy. Okay? This is one of the first items that tends to be endorsed. So we look at the different levels of the Likert type item here, and we still see a problem with the item. Whereas the other items, this item being the perfect example here, number 73, love to hear about different countries and cultures. The levels on this item look good. They go 1, 2, 3, 4, 5. They're in order, and so there's no disorder here, and they span a great amount, they span a great distance of the construct. So this is a great item here, number 73, at least in terms of this parameter. Our item 81, however, doesn't look so good because the different levels of the item are still disordered. 3, 2, 1, now that shouldn't be there. Why is that there? 3, 2, 1, 4, 5. So that's telling us that there's some kind of problem with the item. We want to find out what that problem is. Go back to the item polarity table and scroll down. Remember, the item polarity table is on the diagnosis menu. So pop up the item polarity table in Notepad, scroll down until you find item 81, and that's going to give us the frequency in terms of percentages, raw numbers and percentages of subjects that endorse each level of the item. Is everyone able to do that? Okay, so the question is, why are these different levels, why are these levels of the item distorted, or why are they disordered? The item, I'm interested in many things, sounds like it should be right on construct. It's curiosity, right? So I'm interested in many things should be right on construct, and yet the graph is showing us that the levels of the item are distorted. There must be something that accounts for that. We go to the item polarity table, we look at the percentage of subjects that are actually in the first 3 levels of the item. What we find out is that the item is highly skewed and that the first 3 levels of the item actually comprise only 9% of the subjects in the sample. So just about everybody agrees or strongly agrees with this item. Because there are so few subjects in these levels of the item, it means that the difficulty value, the difficulty of these levels is difficult to estimate, difficult for the statistical model to estimate. And that's why we have this situation where the item is narrow and disordered here, because we have so few subjects endorsing the item at that level. Okay? So the question is, well, is this a good item or a bad item? Well, it's probably a bad item because the item is so skewed that its difficulty levels cannot be estimated satisfactorily in a normal sample. In my opinion, this item would probably be an item that would just go ahead and be deleted. If you want to go ahead and go to the item map, which is on the output tables menu, go ahead and take a look at the item map. Was everybody able to look at the item map? Okay, so the item map puts the persons and the items in the same frame of reference, and you can see that this is the, over here on the left, there's a horizontal or a vertical line here. Just to the left of this, you see this letter M. This is the mean of the person abilities. Here is the mean of the item difficulties. There's something like about 1 or 1.2 logits difference between the item difficulties and the person abilities. Logits are our interval of measurement in the Rasch model. It's an abstract unit of measurement that doesn't conform to anything in the physical world, okay, because it's derived from our statistical model. So the mean of the item difficulties by convention is 0, okay. We can look at the distance between the mean of the person abilities and item difficulties in order to get an idea of targeting. We see that this item down here, I'm interested in many things, is actually down here at the bottom in terms of the item difficulties. This is the easiest item. Not only is it an easy item relative to the mean of the item difficulties, it's a hugely easy item relative to the mean of the person abilities, and that's why the item is so skewed. Okay, so again, we just delete the item, bad item. Now, in terms of new stuff, we want to take a look at how do we identify clones, or what in the Rasch model are going to be called dependent items. When we dealt with this issue earlier, we just, in SPSS, we tried to look at items that were correlated, say 0.50 or above. And if items were correlated 0.50 or above, well, we were tempted to we looked at their phrasing, and if the items were too similar, well, we decided that the items were clones and we would just delete them. But there wasn't really an easy way of identifying clones, or what the Rasch model is going to call dependent items. In WinSteps, we have a way of looking at this exactly. So in terms of what is a dependent item, you can think of a dependent item this way. There's different ways of phrasing this. They all mean the same thing. One way of phrasing this is that items should be alike in that they tap the Rasch dimension and different in every other way. Okay, this is also known as the assumption of local independence. Sometimes you'll hear people say that the item residual should be randomly distributed around the dimension of the construct. Statistically, all of these mean the same thing. Another way of expressing this idea is to say that the item residuals with the Rasch dimension removed should be 0. Okay? So if the variance which is specific to each item, if the residual variance of each item is in fact randomly distributed around the construct, around the dimension of the construct, then we would expect that the correlation between these residuals should be 0. That may be too much vocabulary right now, but it'll become apparent as time moves forward. All right. So the way that we want to assess, the way that we want to find dependent items, go to the diagnosis menu and choose the dimensionality map. And we're going to get to what the dimensionality map is next lecture. We'll talk about that in depth. But for right now, just go to the diagnosis menu, choose dimensionality map, and scroll all the way down. So Mike Lineker, genius as he is actually able to give us the correlations of the item residuals with the Rasch dimension removed. Mike actually gives us a list of the largest of these correlations. You're looking for correlations that are outside the range of 0.30 to minus 0.30. If two item residuals are correlated, say 0.31, well, that's going to be suspicious to you. You're going to look at that. You're going to look at the phrasing of the item, and the question is, are these items too closely phrased? All right? When you analyze the IP-VIA data in class a little bit later, you may find items that are closely phrased, but they're only correlated 0.20, say. The reason for this is that the IP data were gathered over a 10-year period. So there's occasion variance that's thrown in here that wouldn't exist in most data sets where all of the students or all of the subjects take the test at the same time. So here is an actual result, but this is actually on the perspective or wisdom scale. And what this shows is that the correlation between these two items at the top here is 0.39. And if we look at the text of the item is, one of the items is consider myself to be a wise person, and the second item is am considered to be a wise person. Okay? This is not the curiosity scale, this is the wisdom scale, but I just wanted an example to show you. So obviously, consider myself to be a wise person and considered to be a wise person, these items are very closely phrased. The correlation between the item residuals with the Rasch dimension removed is 0.39. That is too high. You can see that those items are contributing to what we would call a secondary dimension in the data. Okay, these items are they're measuring something which is in addition to the construct, and since these items are correlated too highly, one of those items obviously should be thrown out. Now, which item gets thrown out? We've got two items that are too closely phrased. We want to throw out one of the items. Which item gets thrown out? Well, to decide that, you have to go back and check the empirical item categories table. You have to check the point measure correlation. You have to check the fit statistics. In other words, there's a variety of statistics that you can look at to decide which of the items actually gets deleted, but we know that one of these items is going to go. Just looking at this table, we know that one of these items is going to go. Okay? So what is the general strategy for item selection here? The first thing you're going to do when you select an item, you're going to look for dependent items, just as you did when we worked with SPSS earlier. The first thing you do is try to eliminate clones. So first thing you'll do, you'll go to the diagnosis menu, you'll select the dimensionality map, you'll scroll all the way down, you'll find the dependent items. Maybe the scale that you'll be working with, you'll have no dependent items, and it won't be something you'll have to worry about. If you do have dependent items, that is items that are correlated beyond about 0.30, and you need to delete one of them, then you're going to have to go back and look at the point measure correlation, the fit statistics, and the empirical item categories table. So there's multiple statistical criteria to decide. And you basically pick the item that has the most strikes against it if the item had bad fit statistics, if one of the items, let's say that you have item A and item B, they're correlated 0.40, one of the items has to go. Item A has a bad fit statistic of 1.5, that's a strike against the item. Item A has a bad point measure correlation of 0.2, that's another strike against the item. Find the item with the most strikes against it, and that item has to be deleted. All right, so you're going to be, in just a few minutes, you'll be analyzing the VIA IP data. How do you delete an item from this data? Okay, I want you to go back to the command file, open the command file again, and I'm going to show you the procedure that I use to delete items from a command file. So was everyone able to open the command file? What's that, AJ? The command file for the VIA items. The current one you're analyzing. It's on the File menu or the Edit menu. Okay, so go ahead and scroll down to the item text where you actually see the text of the items. And the example that I'm using here is just the items from the Appreciation of Beauty scale. And in many cases, it may not be exactly clear to you which items should be deleted. You may find items that have multiple strikes against them. So you find one item where the fit statistics are extreme. You find another item that has a low point measure correlation. You find another item that's a dependent item. There are many pathways that you could take through the items in order to delete items. Different people might choose a different pathway. So the first thing to do, you're going to change the iSelect statement to be the scale that you want to edit. Different students have different scales assigned to them in the class, right? So you're going to scroll down and change the iSelect statement to be the abbreviation of the first few characters. All right, so for Appreciation of Beauty, the scale abbreviation was ABE. If you wanted to analyze the Appreciation of Beauty items, you would change the iSelect statement to be iSelect equals ABE. Okay? After you've done that and you've looked at some output, you're going to delete items. And in order to delete an item, I just put an X in front of the item. Okay? Because remember, iSelect tries to match the spelling of the item. So if I put an X in front of ABE, that item will no longer be selected into the analysis anymore. The X means the item has been crossed out. So for the first round of item selection, I just put an X1 in front of the item, and then I put the reason. So I might, for example, put X1 high outfit 1.9, and that's going to mean to me that item was deleted on the first round of item selection, and the reason it was deleted was because I found that this item, the outfit of this item was 1.9, which is too high. That's beyond the 1.4 threshold. Okay? And then for the next round of item selection, I would put X2 dash dependent item, or I might put X2 dash low item scale correlation, or X2 dash disordered categories, or X2 dash narrow item, meaning that the empirical item categories were too narrow. All right, so there are a variety of different reasons why you could delete an item, and you can enter these reasons directly into the command file. Okay. Now, another thing that you need to know when you look at the empirical item categories, when you look at the item polarity table, remember that there was a column on the left that gave you the entry of the item. The first item, is it item number 1? Is it item number 3? Is it item number 81? Where at in the command file do you actually see what the item number is? And that's actually at the end of each one of the item texts. That's over here on the end. So, for example, the first item, failed to notice beauty until others comment on it. That's item number 1, and you see this over at the end. So if you need to identify an item by its entry number, that's at the end. Obviously, you can also identify items by their phrasing or through their abbreviation. Okay? So every time you make a change, you're going to save your changes, and then you'll exit and restart WinSteps, because that's the workflow. So that's actually how you'll delete items. What I want you to do is get started on this today in class, and you've got AJ there to help you. He knows this backwards and forwards, and you will look at the data in the item polarity table, the empirical item categories, you'll look at the dependent item stuff, and you'll look at the internal consistency. That's the alpha. And remember, the internal consistency can be found on the separation table. That's in the middle of the separation table. Okay? So you'll just look at that stuff, and you'll just try to do some item selection today. And the first thing that you will do is change the iSelect statement so that it analyzes the items that are on the scales that were assigned to you. Okay? And that's it. And go ahead and get started. And good luck. You're going to use the IP data from the VIA that we had already analyzed. And that's right. Choose one of the scales that's assigned to you and go ahead and begin analyzing that. All right. So I'm going to sign off, guys, and leave you in the hands of AJ. So, bye-bye.